here and present our technology and our company in this beautiful city of Chemnitz. Thank you for the hospitality and thank you for the opportunity. My name is Ervin Tal-Gutelmacher. I am the CEO of Hydrolife, which is a startup company focusing on hydrogen technologies. Practically, we develop fuel cells and electrolyzers based on a novel anion exchange, alkaline exchange membrane technology.
Thank you. So, the second Israel company, David, please introduce yourself.
Hello everybody, I'm actually English. I moved to Israel about 8 years ago, primarily for the startup scene and all the technology that's coming out of Israel, and I want to be part of it. But firstly, thank you guys for hosting. You've done absolutely amazing work, and congratulations on the grant money that's started up our hydrogen economy here. I wish you the best of success. It's going to be an absolutely amazing region here. Chemnitz has a lot to offer. So my name is David Suter. I'm the CEO of FastSense. We're effectively a gas analyzer. We're a nano sensor, the size of a chip. We basically take what the equivalent of what a chromatograph machine can do, so this kind of size instrument, and we put it on a coin size a nano chip. We effectively monitor the transition from methane to hydrogen, so the net zero transition into hydrogen needs to be monitored. There's some beautiful instruments and beautiful tools that are coming out in the industry. They need to be monitored, the data needs to be efficient, and effectively that's what we're doing. We're quantifying the gas, understanding the quality of the gas, understanding the calorific value of the gas, and ensuring that if there's any safety issues, we obviously nip it in the bud, and obviously understand the energy that's being produced from hydrogen itself.
Okay, thank you. I think it will be a fit very good, Hans-Ulrich Werner, and because you will make gas or hydrogen. Can you explain what you do?
Okay, my name is Hans-Ulrich Werner. I'm the CEO of the company Metallic, and we are producing green hydrogen. We have hydrogen on demand. On each place in the world you can have it green. That's all.
Okay, I think you can explain later how we do it, how you do it. Okay. So last but not least, Philip. Yes, you are used the hydrogen for your applications. What are you doing?
Yeah, we're using the hydrogen in aircraft. My name is Philipp Schäffel. I'm CEO of Arcus Aviation Engineering. We are located east of Berlin, not so far away like you have to travel. But yeah, maybe your travel will be soon possible with zero emission aircrafts. And these are aircrafts we are building, and you tell me when it's time to show a little video about what we are doing.
We look forward to it.
Sorry?
We look forward to the time that we'll be all flying in your airplane.
Yes, I think once you have to go back with fossil fuel, you have to not wait too long, but next time. Yeah.
Okay. Yes, I know that Philip came with her own plane here to Chemnitz.
A lot of carbon emissions today.
Yes. On the international airport Yachtsport. But yes, I'm very excited if you try or if you fly with hydrogen. Okay, thank you for your introduction. And Thomas, please, last introduction, perhaps for your chair, perhaps.
Yeah, often thank you for the opportunity. Because of course, often the part of the university is a bit too small in terms of hydrogen is overwhelming. But besides, I'm the head of the chair for advanced powertrains, and we're working on as the name says, on electric mobility, e-mobility. Not only with hydrogen fuel cells, we also look at conventional drivetrains. Of course, we have to teach the students how combustion engines work still, because we will see definitely also, let's say 20, 30 years in combustion engines on the streets, because they won't disappear tomorrow. So an engineer coming from our university should, of course, still know how a combustion engine works, but we have more detailed modules on hydrogen, fuel cells, electric hybrid powertrains, energy flows in these powertrains. So hopefully very interesting things, and hopefully we will perhaps see some Israeli students in the future at our university.
Thank you. So, Thomas, your keynote was very interesting, I think. So I can remember 2012, we were together in Canada, Quebec. So, and there we saw the first steps for electromobility there in Canada. And I can remember that you discussed the terms of hydrogen there, and nobody was interested in it. So I think you was before the right time. So actually you are on time. So, and it's the term in Germany, it will be discussed every day with engineering, with mobility, with something like this. So my first question is there. How will be hydrogen come? Is this more an industrial part? Is it more a mobility part? What do you think? Where is the first step?
The first step is what we nowadays see is that most of the first steps we see around the world are hydrogen generation. Why? Because we have to solve this chicken-egg problem. Everyone says if we have an application. I showed our very first Passats from Volkswagen at the Beijing Olympic Games in 2008, and the Chinese Ministry of Science and Technology was very interested, and they wanted to push the technology very hard. So they had the application, but when the question was there, but where from we get the hydrogen, they said, okay, we get the hydrogen from gas and from coal. I said, okay, that's of course not the solution. For the future, we need to have green hydrogen, and that is why to solve this chicken-egg problem, we need green electricity, green hydrogen at last, as a medium, and that's why I think, first of all, we have to generate hydrogen somehow with electrolyzers, best with electrolyzers, alkaline or PEM or high temperature, whatever. But, as said in my lecture, in my talk, we in parallel need to develop intensively the applications, because the other way around, we won't have the applications ready when there is hydrogen. And to come to the overall picture of a hydrogen economy around the world, we need both. We need all three or four things: transport, storage, generation, and the application in each sector. That is, of course, very, very hard, expensive, will need a lot of time, but let's do it.
David, what do you think is there your business case?
So we are a spin-off from Baylor University, and in order to get this hydrogen right, we need to, I think like Professor say, understand the use cases that are the low-hanging fruits, the people that are actually needing to lower their capex, cost of ownership, carbon credits, now methane credits are coming into play. I know that European legislation has now instated a heavy methane credit, which is I think a few $100 a tonne. It's big money, and so this time it's actually going to come from the industry. So the industry are going to lead. They're going to want to reduce their overheads. They're going to reduce the tax that they're paying. So I was speaking to like a gentleman, Michael, yesterday, and I think that you know, the equipment needs to be hydrogen ready. So I was involved in a project in the UK where they started a first hydrogen purpose-built home, because the gas networks understood that by reducing the blend, by putting blended hydrogen into the gas networks, they will. It's almost like 2.5, 3 million cars off the road. So I think there's two approaches. I think transportation is essential. The long haul, the non-stop journeys. I think cars, the short mile, 1 last mile is obviously needs to be tackled. But it will come from the industry. So I think anyone needs to save carbon credits, methane credits, needs to be looking at for us, our sensors in their equipment, making sure that the equipment is ready by 2024, 2025. So when hydrogen does become price parity with natural gas and methane, we're good to go.
Okay, and with your electric components, you check the quality of the gas. That's right.
Correct. So with steel manufacturing, for example, there's a beautiful process where they heat up the ore with methane, and the way to the future of steel would be to use carbon capture technology to capture the carbon, repurpose that carbon, mix it in beautifully with some hydrogen, and then you've got methane again. So you're really upcycling that carbon capture. You're using hydrogen, green hydrogen, and then all of a sudden, you've got carbon zero steel coming out into the cars, into the trains, into the planes, and that's the future.
Okay. So you are now in Germany here. So you are now in Saxony here. What is your aim here? To find companies they produce for you? To find companies they work with you together? Or what is your aim here?
I think, again, just to say what the professor was saying, that it's all about synergistic relationships at the moment. And, I think the whole purpose of this conference was to understand how we can both learn from each other from a startup perspective and from an industry perspective. Now, Israel is brilliant brains, just like you guys. We are engineers at the heart. We know exactly what we're doing in terms of engineering. But we don't have on the ground facilities to really take to the next level. Israel's great at data because most of our projects, our exits, our startups sell abroad. Okay, so we can test platforms, we can test algorithms with countries from around the world. It's not a problem. You can do that from Israel through compute. Whereas hydrogen, deep tech, hard tech is a little bit different because you need to be on the ground, and I think that Chemnitz is an ideal place in order to get these pilots, these small stages, baby footsteps to this hydrogen economy. You've got plenty of manufacturing, plenty of room to grow your team here, your engineers here. So I think from our perspective, we are looking for some kind of bilateral agreement. I know there's a 2-2 approach where we have an educational partner in Israel and a startup like ourselves, and same here, some kind of corporate manufacturer here in Chemnitz, and a good educational system like Professor's got.
Okay, David, thank you. Hans Ulrich, you know the industry here in Chemnitz. Do you think is it possible that we find for David a solution?
Yes, I think so. The situation is, as Professor Unwerth told, that the situation of the suppliers of the car industry get in the future some problems. You remember on one page that you have seen that the components of the car with a combustion engine are a lot of, and the components of a battery car are also of a hydrogen car, more or less. So some companies are losing their projects, are losing their work in the future, also in the near future, and so we get some problems here. So the result is a lot of companies are searching for new applications, and I think there are a lot of applications. If you think on trains, if you think on trucks, if you think on airplanes, there are a lot of applications, and the companies can use the enormous knowledge from the last years to building new projects, to building new business. And so I think if you are searching in this region some contacts, you are right here. Chemnitz was in the past the most important industrial city in Europe. A lot of companies come from here, a lot of important people come from here. So only to say the 4 rings from the brand Audi comes from here, from this region. All 4 rings. So only to say this. And that's why I think this is a very good thing to look here. Engineers, a lot of people, and I hope we are sympathetic.
Okay, thank you. So, yes, we are. So you have an own industrial company, with his own history. I think 2 years ago or 3 years ago, you founded the Metallic Cube company, and you made the step that you say, okay, I need a new product, or I need a new technology for my future. Now, can you explain what you are doing with Metallic Cube, or what you are willing to do?
It's not so easy to say in some words because of less time we have. But only to say this, we are producing green hydrogen. We have a worldwide patented system. You cannot read a lot about us because we have made a lot of NDAs with some companies. And I will only pick one example from the industry. I can say an example from the glass industry. We get orders. The glass industry needs gas. The glass industry needs also soda, which is sodium carbonate. And we are producing hydrogen from sodium. Sodium in Germany, in German language, is natrium. Only solid natrium, sodium, and we add water, and we get in hydrogen. And the byproduct is sodium hydroxide, and this byproduct is able to grab CO2, and the result is sodium carbonate. So the glass industry is using all these products, is using the hydrogen for burning, is using the soda for the raw materials they need every day, and they are also saving the CO2 certificates that they have not to buy. So it is a triple win-win situation, and so we get some orders on this, and it's only one example of this technology.
Okay, thank you. Very interesting what you do.
I hope.
So, you are very strong in components of fuel cells. Can I explain something? And you are here in Germany, and you have an aim. What is your aim?
Well, practically, we have been pioneers in this anion exchange alkaline membrane fuel cell technology, which we have developed it up to a TRL7, and we are prototyping and field testing this prototype in Israel. And the reason that, one of the reasons of my visit here was the competitiveness of this region, especially as Professor Van Unwerth said before, with the hydrogen expertise in terms of the manufacturing, in terms of the infrastructure for field testing, in terms of having such a center or such a competence background in hydrogen and manufacturing as a platform for technology, novel technology demonstration, test benching, comparison, and maybe in a later stage also standardization, because we are talking about a technology that has the potential to bring down the costs while maintaining the performance, maintaining the durability, let's say, and the lifetime of this kind of fuel cell systems, with the potential to meet the cost targets. So,
I will add some words on this because one bottleneck of using hydrogen in mobile applications is, Professor Unwerth, is the fuel cell. Yes, that's right. Absolutely clear. The price of a fuel cell is too high. It comes from low pieces production. Only 2 companies worldwide producing a mid-size amount of fuel cells. Should I tell these 2 companies? Better not. Toyota and Hyundai are producing this bigger amount, but for using hydrogen in mobile applications is a bottleneck. Totally clear, it's the fuel cell. And only to say and only to remember, important material of a fuel cell is platinum, and only to remember, more than 60% of the raw materials of platinum comes from Russia, for instance. So we cannot buy at the moment this, and it is a bottleneck, and we need a lot of research and development that we are producing fuel cells with simple materials. That's one of your strengths of your business, yes?
Exactly.
Yeah, exactly that.
And that's the same for electrolyzers. And
Yeah.
what's also important to mention is that we need the manufacturing technologies. One point why the fuel cell and why the electrolyzer is still so expensive, because there are no, let's say, pilot lines for serious production. If you see the manufacturing of a combustion engine nowadays, we have a plant from Volkswagen here at Chemnitz. They produce each day 1,000 combustion engines. They have, of course, an overall facility only doing this. And that is what we would need for fuel cells, for electrolytes, for each component. We need to manufacture bipolar plates, membrane electrode assemblies. We need to have the catalyst, the raw materials, and so on. So the overall value chain, to install the overall value chain, including the manufacturing processes, it's a long way to go. And in the end, then we can come to the cost target, and then we can produce efficiently all the components. I think that is also one aim for you to come to serious production for electrolyzers, isn't it?
Exactly. First of all, for fuel cells and electrolyzers, especially as you mentioned, the bipolar plates, starting with the mere components like the bipolar plates, the MEA, the making this very, let's say, unique manufacturing process being viable for mass manufacturing, for industrialization. And when we talk about gigawatt, and we just discussed, it's not only gigawatt, it's going to be terawatt, and this is something that for sure will need the implementation of industrialization, mass manufacturing processes, which today practically are not there. So also these processes need to be developed together with the technologies, the novel technologies that we develop, bringing the cost down to meet the cost of a diesel engine, or the for fuel cells, or the cost for gray hydrogen today, or gasoline for electrolyzers. So there is quite a lot that we believe our alkaline exchange membrane technology can bring on the table in terms of cost reduction, both for hydrogen generation and hydrogen conversion, especially when we talk about CAPEX, but not only CAPEX. But for the short-term market entry, this is what matters. CapEx really matters. So this is one of the benefits that our technology can present.
Perfect, thank you. I think this is very interesting. And Philip, this is also a solution for you. A cheap Fursau.
Yes, as cheaper as better, always. That's very clear. But what is not only a problem to have not the mass production yet, it's a big chance for small and medium enterprises. A big chance, because we have this industrial revolution right now. The big companies need big markets, but the small companies can live with small markets, and that's also our chance. Many people ask how you can produce an aircraft, how you want to enter the market. Yeah, it's exactly our niche. You know? We can start with smaller aircrafts now to set up the technology. So I think that's what we all do here, and attack the bigger players in this moment. It's fun. It's a great competition.
Last question. Do you think that hydrogen is the key of the free emission flying?
Today there's no better solution so far. In aviation everything is about energy density, and when we exclude fossil fuels, what have something around 12,000 watt-hours per kilogram, there's nothing until we come to the hydrogen including the tank. And when we talk about hydrogen including the tank, we are something around 3,000 watt-hours per hour. So a quarter is really painful for aircrafts, but there's no chance the battery knows at 200 watt-hours per kilogram. Only the battery, honestly speaking. We have to include also the rest of the high voltage converters, and cabling and so on. So battery is not a solution. Beside of nuclear power, there's nothing else. So hydrogen is the only thing we have. And that's what I should add to your solution, as your best advertiser maybe. What Hans-Ulrich is developing is one of the safest hydrogen storage systems that we know, with versus energy density. Of course, we know metal hydrogen, but here we are in our system something around 1,000 watt-hours per kilogram. It cannot explode. Yeah? And you had it in your presentation before. One of the most important arguments to get into the market is safety. The customer will not buy something that is not safe. And that will be definitely one of the solutions. For stationary systems, no problem, we can go far away from it. Yeah? But when you are in the car, in the airplane, you struggle with that. And even batteries, at least nowadays, have these problems. We know that all. This is a mass market already, and once some battery burns, it is. We still know the name Samsung from the airplane, that they say as somebody has a Samsung phone in the pocket. So you can make advertising from that, but this is bad advertising. So that's what I wanted to add to your system, and once again the chance for the small companies to come up with some real nice innovations.
Okay, thank you. Yes, last questions. Thomas, Philip said safety is very important. Are you researching safety, or is it, you think, is it a solution that there is there? It's a solution there for this?
Yes, safety is a big issue, of course, as shown in the presentation. Safety is one of the most important issues concerning almost each application. If it's a mobile phone, or if it's a car, or if it's an airplane, we will do research and development on safety in our innovation center. That's one important main point. in terms of hydrogen safety itself. So what can be done to, for example, to hinder hydrogen to mix with oxygen, to build some critical atmosphere. We do research work on contamination in gases. What happens if you breathe hydrogen or other mixed gases or whatever. In terms of electrical safety, we must not forget that beneath the fuel cell itself, we have a lot of electrical components, like in a battery-driven vehicle or plane or whatever. We have high voltage battery. Additionally, we have a high voltage circuit and so on and so on. So the overall fuel cell system, the overall hydrogen system, has to be absolutely safe. And that is one point why we don't see so many vehicles, doesn't matter if car or lorry or duty vehicle or plane or whatever, nowadays on the street, because the safety issue, everyone, like the big OEMs, they first have an eye on safety, and if it's not absolutely proven, they won't give it in hand of customer. Definitely not. So safety is, yes, a very big issue. We do research on that.
So you have a hydrogen car, yeah? So, and what is your experience with safety?
And once I've been asked, oh, do you feel safe when you're sitting on a bomb? I said, yeah, I'm absolutely safe. Because I'm now working for 30 years with hydrogen. I built own hydrogen cars and other hydrogen vehicles as you, at ICM. Sebastian, you also built up a very cool vehicle running on the hydrogen fuel cell. And I'm absolutely safe because all the components, the hydrogen vessel, the hydrogen system has been proven. It's from Toyota. Toyota is the biggest, I think, nowadays, the biggest car manufacturer. So they did everything to make the car safe. It has a TÜV sign. So I am really sure, even when I'm filling my car at a hydrogen filling station, I don't feel any problems. Because just one example, one story from older days, when I've been filling a hydrogen vehicle prototype in Shanghai, in Beijing, I had a partner, and he had to, because we had a failure on the tank system, he had to defill the tank system. And he opened the valve, and the hydrogen came out, and next to it, 2 meters away, one lit his cigar. And he said, oh wow, what's happening? I said, don't worry, it's 2 meters away, no problem. There was no problem. So hydrogen is not the critical gas that everyone thinks it is. It has to be handled carefully, definitely, like natural gas or gasoline. So safety is an issue, but we have to handle it with respect. But it works, and I'm feeling safe driving my Toyota.
It's the same as natural gas. I'm going to say there was a case study in the UK, and that was the first thing in order to get it into the pipelines was to prove that hydrogen was as safe as natural gas. And we've got to remember, we had a conversation about it, that we had our pipelines were with what do you call it, town gas before. We're used to gas, and the user experience of filling up a gas versus waiting at the car for half an hour, 45 minutes is it's an issue.
David, one question. You have one wish.
I have one, sorry?
You have one wish. So today, which company do you like to join or to bring it with you together?
Well, we believe in baby footsteps. Okay, I think that actually your aeroplane, your small aeroplane, is something I would like to join. I would like all of us here together to put together some kind of synergistic relationship that I was telling you about, because hydrogen is not going to happen overnight. And I think that your approach of coming under the radar, excuse the pun with the airplane, coming under the radar and serving this unmet need is a lot of the big, heavy industry players cannot do. They're not lean, they're not mean, and they definitely can't move as fast as we can. So that's the WhatsApp group that's going to be sent after this meeting. Okay, so last question to you. The same question?
Okay, so first of all, if I had a wish, is to see these hydrogen devices, all the full hydrogen ecosystem being embraced, and we just discussed it. Let's start doing it, because when Ford decided to make an automobile, they didn't think how safe or unsafe was the fossil fuel. Of course, it's flammable. Of course, it's less disposable in air than hydrogen. They just made the automobile and started driving it in US and later on, and then it was there. So the same thing should be done with hydrogen, and we should start by deploying the hydrogen generation there, starting with the mass scale alkaline or PEM or even solid oxide, depending electrolyzers, and we believe that the next generation will follow once you have this infrastructure being built. So my wish would be, for example, to get appointed with a strategic partner from the hydrogen ecosystem that will take the alkaline exchange membrane technology and look at it as the next generation for improving the current, either alkaline, which is very straightforward, technology in terms of the electrolysis and in terms of the fuel cell, namely taking an AEM stack and just implementing it as a better second generation of a traditional alkaline electrolyzer or traditional alkaline fuel cell for stationary and maybe later on mobile applications.
So I think we have here the first project with altogether the application, the solution for the hydrogen cell, you for the safety or for the quality cell, and you for the fuel cell. That's perfect. So let's finish. Thank you very much.
How about, I would like to ask Professor Unwerth about the safety in case of a car accident. I understand that you can, when you have a process, a gas station to fill hydrogen, this is something you can regulate, control, think, but what about the case of car accident? Is it still safe in condition of very high pressure, heat, maybe even fire?
That is also been tested already on many places around the world. Toyota, for example, or Hyundai, they're both manufacturers that have cars running on the street in thousands of pieces. They tested their cars. You can even watch some videos of crash tests on YouTube, and what you see is that you have a highly tight and very strength carbon fiber system with 700 bars pressure inside when it's full, and when the car crashes, the overall tank system goes, let's say, 5 or 10 centimeters to the front of the vehicle, and nothing else happens. And the gas, of course, the crash sensor leads then to a lift, perhaps, to venting the storage compartments, and then hydrogen vents, and even if there's an ignition somewhere, there are also some videos on YouTube, you can look from Ford. 20 years ago, they did research work on that. What happens if you ignite hydrogen, it's coming out of a car venting system. Then you have a flame, like a burning flame, like a candle, and then it burns, the hydrogen is empty, and then that's it. And they measured the temperature, the back of the car was 57 degrees Celsius, something like that, and nothing else happened. Do that with some gasoline-driven cars. So, of course, worst case, if you look at Formula 1, what can happen there? If you drive with 300 kilometers an hour against the wall, of course, that may be a problem. But then you have other problems than the emission of hydrogen.
Thank you.
May I add some words? It's clear we are fans of hydrogen, that's clear. But only remember on the space shuttle, the tank in the middle of the space shuttle, since many years, is filled with hydrogen. And you can see it on a lot of YouTube videos, as you said. You can see it's a safe business. Hydrogen is using a lot of years, and why space shuttle is using this gas? Because the energy density is very high, 3 times higher than diesel, for instance. So that's why they are using this. The only problem is hydrogen is going out for more. And that's why they are filling up to the last second before they are starting. They are filling the hydrogen, the liquid hydrogen, filling in, and only 2 seconds before start they go back with the filling station, and then they go out. If they are waiting maybe, I don't know, 30 seconds, they cannot arrive to the space because the hydrogen goes out because it's liquid. That's why. So only to stay safe.
Thank you.
Good, thank you very much. Das war very interesting. And yes, ich denke, wir sind jetzt am Ende von unserem Panel und Sie können jetzt praktisch sofort in die nächsten Parallelsessions gehen, wenn mich nicht alles täuscht. Herzlichen Dank fürs Zuhören.